Welcome! Today, we're going to jump right into the fascinating world of organic chemistry. We're breaking down two super important types of reactions that let chemists, build and change molecules: addition and substitution.
It almost seems like magic, right? How does that even happen? Well, the answer is pure chemistry. The secret is this really powerful molecular makeover. And we're going to start by looking at the first method, the addition reaction. All right, first up, addition reactions. The best way to think about this is like a molecular renovation. It all kicks off with a special kind of carbon compound, one that isn't quite full yet and has some room to grow. So the secret ingredient here is something called an unsaturated compound. And what makes it unsaturated? It's all about that double bond you see between the carbon atoms. You could almost picture it glowing, right? It's a spot that's just packed with energy and reactive electrons, basically waiting for a chance to pop open and grab onto some new atoms. Okay, and here it is, the magic moment. That double bond literally breaks open, leaving two brand new connection points on those carbon atoms. And just like that, the molecule has made room for new atoms to come join the party. Now, this is a perfect real-world example, something you've definitely seen without even realizing it: making margarine through a process called hydrogenation. You start with a liquid, unsaturated vegetable oil. Then, you bubble hydrogen gas through it with a little help from a catalyst. See that nickel symbol right there? That helps the hydrogen atoms add themselves across that now open double bond. And the result? You get a saturated, solid fat. Okay, but what happens if a molecule is already, full? What if it's saturated, meaning it only has stable single bonds and absolutely no room to add anything else? Well, that's where our second type of reaction comes into play: substitution. So take a look at these guys, like methane, CH4. They're what we call saturated. Every carbon is bonded to the maximum number of atoms it can handle. They're stable, they're happy, and honestly, they're kind of unreactive because there aren't any of those inviting double bonds to break open. It's a really good question. I mean, if you can't add anyone new to the molecule because all the spots are already taken, what's your only other option? Well, you've got to convince someone to swap places. And that is exactly what a substitution reaction is. Instead of adding to the molecule, we're going to replace or substitute one part of it for something else entirely. Let's see how this works with our methane example. So here we've got methane reacting with chlorine. And see that little sun icon? That's not just for decoration. Sunlight provides the burst of energy needed to get this reaction going. A chlorine atom literally kicks a hydrogen atom out and takes its spot. Then, that leftover hydrogen grabs the other chlorine atom. Now here's the key difference. Unlike an addition reaction, you end up with two products, chloromethane and hydrogen chloride. It's a clean swap. So let's put these two head to head. It really all boils down to one fundamental difference, right? One reaction is all about adding new atoms to make the molecule bigger. The other is just about swapping out the atoms that are already there. A side-by-side look makes it totally clear. This chart just lays it all out, nice and simple. Addition starts with an unsaturated molecule, breaks open that double bond, and you end up with one bigger product. Substitution, on the other hand, starts with a saturated molecule, has to break a tougher single bond, and creates two new products. So one expands, the other swaps. That's the whole game. Okay, so why does any of this matter? Believe me, this isn't just some abstract chemistry concept. These two reaction types have huge, real-world applications that affect tons of products we use every single day. Like we've already seen, those addition reactions are essential in the food industry for turning liquid oils into solid fats. Meanwhile, substitution reactions are a crucial first step for creating these incredibly versatile compounds called haloalkanes. And these guys? They become the building blocks for countless things, from refrigerants that keep our food cold to pharmaceuticals that can save lives. It's pretty incredible when you think about it, isn't it? These two simple sets of rules, adding to what's open and swapping what's full, are really the foundation for so much of modern chemistry. Understanding them isn't just about passing a test. It's about understanding how we can build the molecules that are going to shape our future.